This is that percent composition, which, as you can probably figure out, is if you're looking at a molecule, it's like the percentage of all the elements in there. So a percent is always a part for a whole. And so you can look at like the parts. So we were just talking about glucose a minute ago, right? Like, so we can talk about the carbon percentage or the hydrogen percentage or the oxygen percentage that is in that molecule. So a lot of the times we find something that's very useful is called a percent by mass. So if you know the mass of your compound, like what mass of that is carbon, what mass of that is hydrogen. So that's called the percent composition or the percent by mass. So like I said, just like any percentage, a mass percent is the mass of whatever element you're interested in divided by the mass of the whole compound. So the part for the whole times 100. So an example number 4, I said, what is the percent composition of each element in the compound ammonium carbonate? Now, notice I just wrote the name, so you do have to have the correct formula before you actually find the percent composition. So what is ammonium carbonate? Well, ammonium is our only polyatomic ion that is positive. It's NH4 plus. And carbonate, notice it ends in an 8, so that's going to be a polyatomic ion as well, is CO3 2 minus. So if we do our crisscross thing, that means I have 2 ammonium, so that's where we use those parentheses, little 2. And 1, because this is plus 1, carbonate, so just CO3. So this is ammonium carbonate. Now to find the mass percent, I need the mass of the whole thing and the mass of each individual element. Okay, so I'm going to nitrogen, hydrogen, carbon, and oxygen. These are all the elements in here. So by the time we're done, they should add up to 100%. So nitrogen on the periodic table has a mass of 14.0. Now, a lot of the times I have people ask me, how should we round those numbers from the periodic table? Because they have way more decimal places than that. As long as you keep 1 decimal place, you would be fine. All of these just happen to be 0.0. So nitrogen is 14. I have noticed this 2 goes to the whole thing. So I have 2 nitrogens and 8 hydrogens. 2 times 4 would be 8. So I did 14 times 2 is 28 grams. And then hydrogen's mass is 1.0, and I have 8 of them, so that's 8.0 grams. Carbon, I only have 1 carbon here, so it's 12.0 times 1, which is, of course, 12.0. And then I have 3 oxygens, so oxygen mass is 16.0 times 3 is 48. Now, to get the mass of the whole thing, I add these together. So 28, 8, 12, and 48 gives me 96. This is the molar mass of the whole compound. So notice I use the unit grams per mole. That's the molar mass of this guy. So what I did then for each of these numbers, I divided it by 96, 96, 96, 96, and times 100, and I got these percentages. Now, I didn't give you any numbers in the question, so you could have rounded however works for you, but then you'll notice all of these add up to 100%. If you did something weird, you might end up with a percentage that is not 100%, and then you need to go back and check your work because it should all add up to at least very close to 100%. Okay. The most common mistake when we're doing these is some people, if I wanted to know the nitrogen percent, they would just do the mass of 1 nitrogen over 96, but there's actually 2 nitrogens in there. So you need to do 28 over 96.